Hey everyone, and welcome to our event today. Got a lot to do today, so I'm going to try to move rather quickly through this first set. My name is Paul Bemis. I'm the president of Applied Math Modeling. For those of you who don't know us, we have been around since 2008. We come from the Ansys Corporation, or Fluent Ansys Corporation. I worked there for many years, and my background is both mechanical and electrical engineering, and was in the software development business for quite some time. We build the CoolSim application. We also do a lot of modeling work, CFD modeling work primarily. And today we're going to be reviewing the CoolSim tool a little bit and some enhancements we've made to it that I think make it the best in the market. CoolSim is built on the Ansys set of technologies. So that's a cost savings, of course, for our customers because we don't have to build the meshers, the solvers, and the post-processors. We just get to take advantage of them, which is just a wonderful thing. Those are state-of-the-art, the best in the business, market leadership stuff. And CoolSim is an interface built on top of that, and it is a SaaS model, software as a service, client-server implementation. The model builder runs on your desktop, but all the computation for mesh solve post takes place on a dedicated cluster that we put in place for you. So you don't need to have a high-performance machine laying around to run this on. It is designed to run on a laptop and does that just fine. From a Starbucks, no less, because I do that. We are experts in the field of CFD. We do a lot of CFD work outside of data centers as well. So for those of you in the design build area that run into CFD modeling issues, don't be afraid to call us. We focus primarily on data centers, but we do a lot of stuff as well, from casinos to gun ranges. So that's a little bit about us. Today we're going to be talking, I'm going to take a couple of sections and review it. So let's get started. I'm going to first work on Cad Import. I think we are the only ones, as far as I know, that allow this capability to exist the way that it is. Very nice little interface we built for AutoCAD. And Visio as well. A lot of you are using Visio as a layout tool, so the customer is. And it's okay for 2D data center layout. I'm going to show you how to bring those in through AutoCAD and put them into CoolSim. I'm also going to review a model that uses ducts and diffusers. Apparently, we're one of the few, if not the only one, that has a duct tool like we have, which allows you to lay out ducts really efficiently and easily. So I'm going to show you that. And then I'm going to show you some of the new results that are available with CoolSim 4.7. That's our newest release, which are quite nice. So let's get started. The first thing I'm going to show you is importing CAD into CoolSim. This is quite important in a couple of areas. One, if you're a co-location provider, or you manage a data center that has other people's equipment in it that you're renting, or you're selling SLAs, you're selling capacity, then it is likely you've got a layout of that room in AutoCAD or Visio. And you often want to know what's going to happen if you add racks or you're going to sell an SLA to somebody. My best customers in the colo space will use CoolSim as a tool to ensure that the SLA agreement can be met. So the AutoCAD plugin sits inside AutoCAD and allows you inside AutoCAD to basically set the whole model up, including height and plenum depth and rack height and cracks and PDUs and perforated tiles and blocks, all inside AutoCAD. And then you export it. So I'm going to show you a demonstration of that. I'm going to start off with Visio because a lot of you have Visio drawings. Visio doesn't have a tool directly for interfacing to much of anything, but it does have a save as a DWG file format. And the way I'm going to do this today is I've pre-recorded these with Camtasia. I didn't do the audio, I just did the video. So I recorded it in advance, and that allows me to stop it and start it, take questions and things like that without wasting time making a mistake or losing my concentration because I'm working with a GUI instead of talking to you. So here I'm going to go ahead and start this. Now this is quite simple because I'm in Visio right now. This is a Visio drawing, and all I'm going to do is a save as or an export. You can do either. But in this case, I'm going to do a save as. I'm going to save it as an AutoCAD drawing, and I'm going to just save it also as a DWG. So there you have it. There's my DWG. So I've exported it as a DWG, and now I'm going to go get AutoCAD and fire it up, and I'm going to read that DWG into AutoCAD. Now, if you don't have AutoCAD, we have it, so we can do this process for you. Or if you don't have Visio, we can read a Visio and export that too, if you don't own the Visio application. Now, one of the things you have to do, you noticed it complained a little bit, so I'm having to do a copy paste here. So what you have to do once you get inside AutoCAD is you have to copy that image and create a new drawing and paste it in. This is a kind of an artifact of the Visio import feature. But if you just paste it into a new drawing like I did right here, and then Control-C, Control-V it, which is what I did, and get it in, now it is sort of set correctly inside of AutoCAD and will behave itself. Now you do a save as. So that little routine I showed you right there of once it's in, do a copy paste to a new drawing works quite well, and then do a save. So now I've got the AutoCAD drawing inside AutoCAD, and the first thing I need to know is what dimensions of this thing in. And they come in all kinds of dimensions. So the best thing to do is measure something. So now I'm inside of AutoCAD, and I need to know what the size is. So I'm going to use the dimension or measure command inside. You can use either one inside AutoCAD. In this case, I'm going to do distance. What I want to do is measure something to see what this thing was built in, and that's showing 2549. So this thing was built in millimeters, and it is inside AutoCAD in millimeters. So that's kind of important. So what I do now is go to units, do the units command, and set this thing for millimeters. And this tells the CoolSim for AutoCAD tool, the little plugin that sits right here, that this thing's in millimeters. So getting your dimensions right is important. Now I can go to the room, and you see I have height for supply, I have height for plenum, and I have height in the room. So I'm going to, in this case, set the height for 3657 millimeters. Supply plenum I'm going to use, because there is one, I'm going to set it for 1219. Then I'm going to set the height for the return plenum to be 914. I'm going to use diagonal opposites to define this room. And that's because it's got doors. It's not a perfect polygon on the exterior. So I choose the upper left-hand corner, and I go all the way down, and I choose the lower right-hand corner. And when it turns blue, I've got it. So now I've defined the room and its height and its depth. Now I hide that so that I can see other stuff down here, the little hide button. And now I can begin to work on other stuff in the room. And what I'm going to do first is to begin to define the racks. Now we have a new feature in this tool that allows very fast definition of racks. You notice here that once I select the rack tool, I can select the airflow direction, I can select the height, the load, and the incremental direction of the racks. So first I'm going to set the rack height, 2133. I've got 4 of them there, 5 of them there. They're headed in the -y direction, negative y, and the airflow direction I'm going to choose here. So there's my direction of incremental rack, and then I'm going to do internal selection because that's a polygon. And I pick the first one to make sure I've got it right, and then I just use my counter to bang out the others. Boom. I just laid out 5 racks. I got the airflow direction right. I've got the loads in there. These can be edited using the edit rack command at the bottom. But for now, I'm just going to go ahead and lay them out. I pick the first one, make sure my airflow direction is right. I count down to see how many I have in the list. I count down, in this case, I have 16, or 11. And each time I use the done command to reset that counter to 1. So here, again, I've got 4. And the nice thing here is if your racks are the same size, you can just continue to bang these out. And you can do them as a group, or you can use the little increment button on the quantity pull down, which is right here. This little quantity, you can increment it up and down. Here I'm changing the airflow direction now because this is going to be hot out, cold out. I zoom in a little bit so that I can close enough to pick that polygon, and then I just count down to determine how many I want. So generally what I do is pick the first one, make sure I like it, make sure I've got airflow direction correct, then I count up the number and I just wipe out the 1 and replace it with the 16. Boom, got them. I have to hit the done button to reset that counter, and then I do it again for this guy. You can edit the list. I'll show you that in a moment if you want to keep the names in there, because right now it's incrementing them as rack 1, rack 2, etc. But you can also put those labels in if you want, right from here, and just keystroke those in. You have to zoom in a little on the drawing to be able to pick up the polygon sometimes. But here I'm going to just pick this one. I'm going to count up the number of racks there are here. And I think we've got 16 again. And just put in 16. And it gives me them all. Very, very fast. This is the fastest tool I've ever seen to do this kind of work. And it captures a lot of data. If any of you have done this by hand with counting tiles from a PDF, or you've done it from something where you've had to create in one of the CFD tools by counting tiles, it's tedious. And this saves a tremendous amount of time. It puts all your geometry in the right location. All of this can be edited on the CoolSim side once it comes in. So I just keep on going here, and it's a very quick way, particularly for racks, to be able to get the quantities, get the locations, get the airflow directions, get the heights. Loads, I just default it to 4kW. You can change loads on the other side. You can change loads in the edit sheet down below. Rack edit down here. You could open rack edit and change loads if you want down here when you're working inside the tool. So if you want to get the loads close, you can do it here. If you want to wait till you get to the CoolSim side, you can do it there too. And I'm just going to pick up the remainder of these over here. I'm going to go negative X because that's going to be the airflow direction. I'm going to get the quantity, 5, internal selection, boom. If it's a polygon, a closed polygon like we're showing here, this internal selection is the fastest way to do it. You can also use diagonal opposites, but the fastest way to do it is internal selection. So there I have my racks. Like I said, I can edit those racks using the edit rack command. I can pick any one I want. I can change the label. I can change the loads. I can't change the height because they're rack rows, but you can change them on the CoolSim side if you need to. So now here I'm going to go for blocks. Now I'm going to use diagonal block opposites on the block because that's a solid polygon. So I'm just going to pick the 2 corners and grab that, and then I'm going to go here and just walk across it and pick the 2 corners for each one of them, and select those pillars that are in the room. So we can pick up blocks, racks, we can do cracks, we can do PDUs, we can do floor tiles. Now, I don't see a lot of floor tile definition in these drawings. For my DWGs and even Visios, I am not seeing the floor tiles be put in yet. So generally, you got to do those in a subsequent step on the CoolSim side. But there's my racks, and now I'm going to go for PDUs. Now, once in a while, you'll notice here during the sequence that it's going to pick that PDU wrong. When I do internal polygons, every once in a while, it'll get to a point where it doesn't pick it quite right. Here, I'm going to set the height to be 900 millimeters, and I'm going to try to do oh, I see, it's on diagonal opposite. That's why I did it. So I'm going to try internal polygon. I'm going to try to pick that, and you got to zoom in sometimes to get it, and you'll notice once in a while it doesn't get it quite right. So you can always use diagonal opposites, and there it selected part of it. Don't worry so much because later on you can fix it on the CoolSim side. And here, internal selection, I'm going to try it again. Oh, that one worked. And so when it does work, it's very fast. So just grab them, walk across the drawing inside AutoCAD, and just pick these. These are all being built inside of an overlay that sits inside of AutoCAD. So it's actually being added to the DWG drawing that we had. It can be edited at any time later. So there's my PDUs on that side, and then I go down here. I mean, selecting polygons is just easy. And of course, you can, again, change the labels if you want. So you can make that a 1B or whatever you like when you use the edit command for the list. So everything can be done here to lay out this room, which just speeds up the process tremendously. Even if you have to make adjustments on the other side, on the CoolSim side, it's still very fast to get this thing laid out so that you don't have to spend a lot of time with 2 applications open, trying to make measurements and figuring out where stuff goes in this plane. So now I'm going to do my cracks. The cracks are the same way. We don't have a counter for cracks because there's usually not that many and they're fast to do. So here we're going to do internal selection. I'm going to set the height for 1800 millimeters and I'm just going to pick them. So sometimes you're going to zoom in a little bit. So you zoom in, bang, got it. And then you just drag around the image and grab each one of them one after another. Again, you can edit as you want to. These are downflows. You can choose downflow, upflow, or front flow. You can choose 3. So if these are in-row cooling units, you'd use front flow. Upflow is obvious, and these are, of course, downflow. So I'm just going to walk through this drawing and pick each one of these, and then we'll move on from there. So there they are, each one. You can edit it all later, or you can edit the list now. But in either case, we're getting the spatial positioning of this all correct, and we're going to import this. So there's my basic layout right there. I've got my cracks, my racks. So now I'm going to do an export. So I export it as a file. CFA stands for CoolSim for AutoCAD, of course. So I'm going to export it. I say a save. Now it writes it out, exported successfully. Now I go into CoolSim. I fire up CoolSim, which I happen to have a copy of right here. And I'm going to do a file read. I'm going to do a file import. Very simple thing to do. So I fire up CoolSim, and we have made a specific read for these files that handles all of the translation related to coordinate systems, axes, etc. Because our axes are not the same as AutoCAD. We use a right-hand coordinate system, but Y protrudes in the vertical direction. And there you have it. So there's your layout. And notice crack extensions have been put on. CoolSim's smart, so it knows that if it's a raised floor data center and it's got a ceiling plenum return, then the chances are pretty good that it's got ceiling extensions on it. You can turn those off, but it's going to use them. And from here, now we would just go into this and begin to edit. And you'll notice if I open a rack up, everything's laying there. If I used labels, all those labels would come through. I did not use labels in this case, so it comes through as rack 1, rack 2, rack 3 with the loads I had on the other side. But this can all be edited. This is Rack Builder. It's made to look like a spreadsheet. Each one of those cells is a U. We're looking at the front of the racks. You can do average watts per rack if you like, or if you know that it's a 2 kW in this case, but the 2 kW rack server is located here in these 7 U's, each one of those is a U, you can just open up the little editor here and say, you know, it's really 4 kW, and this happens to be an IBM machine, and it's 25 degrees Fahrenheit delta T across it. If I've got a gap, I can put a gap in. We can gap all the way down to a single U, 1.75 inches in a 20,000 square foot data center, not a problem. This thing has a great mesher and a great solver. So there you see it. You can see the gap. So if they didn't blank, you can identify that. If you want to get more specific about your loads, you can do that with individual rack builder. Here I'm going to lay in some tiles, some perforated tiles. So here I want to rotate these into position, and then I want to get a quantity. So same thing, we do tile rows. It's much more efficient. You just type in a number, boom, lays them in. These happen to be all the same percent area open, although you can, under the specifications tab, you can set that too, so that they're not all the same. They are different as it goes down the line. But here I start off usually with 25 percenters, and then I modify appropriately. So I drag this down into position. We snap to the tile with our perforated tiles. We snap to the grid because that's a 2x2 grid. I got to get the quantity right. We support Control-C, Control-V of everything. So I Control-C it, and then I just Control-V it. So once I have it set to approximately the right length, I just drag it, Control-C, Control-V it, and drag it into position. Now I notice the grid's not lined up perfectly here, and that's often because there's an offset, you know, on the tile. The tile is not matching the edge of the room perfectly. And that's often the case, and you can see here that it's probably the case because it's unlikely those racks are off by that much. Now, a visual inspection will determine this for you, but if you don't have the visual inspection or you want to change it, so that it is lined up correctly, just go to geometry and we have something called tile offset. So I'm going to offset it a foot in the X direction to get those racks to line up with those perforated tiles a little nicer. And you hit the OK button and it adjusts the entire grid, so now it's offset by 1 foot on the left-hand side. Just now drag your tiles and they'll snap into place. And occasionally you'll see the one over on the right needs to be refreshed. I did a Control-C, Control-V to get the second set in there. I'm going to change the quantities here. This one needs to be set and it needs to be refreshed. You just increment the counter. It's too long anyway, so you can click it down a couple of notches and get the length right. So the Control-C, Control-V sequence is really handy to have, because once you've done something once, it's tedious to do it again. So just grab it and Control-C it. You can also group it and clone it. If you have symmetry in the room, that's very handy. Sometimes you have symmetry, things are very symmetrical, like pods, which have containment and racks and everything in them. And you're able to group the whole thing and then either Control-C, Control-V the group or clone the group. Clone is the idea of copy with offset n times. And that's a very handy thing. People really like that about CoolSim. So here I'm just laying in the tiles just so we can do that and get the quantities right. And we're using Control-C, Control-V mostly in this case because the symmetry was not perfect enough. Now those racks are still not lined up perfectly. We have an alignment tool, so I grab that one, Control-C, grab that one, put my cursor over the one I want to hold constant and say close gaps in this case X. Do the same thing here, close gaps in X, and it will line those up perfectly. Now maybe they weren't, and so you want to leave them, but if you do want to line them up, do it, because the mesher will be happy and it will run faster. So now I'm just going to do a save. I've got this to a certain point. I'm pretty happy with it, and I'm just going to save it off. I haven't done that yet. There is a backup that's built in the background of CoolSim, so if you have any trouble, there is usually a backup. I think it's done every 10 minutes. So you may lose 10 minutes worth of work, but not more than that, and go ahead and do a save. So that's how you quickly lay it out from CAD. I went through most of that sequence with you right there. So it didn't take much longer than what it took me in that animated sequence. And you've got everything in there. So there's our model. And of course, now if you want to do a run, you can just do it. But there it is sitting there, and that's in pretty good shape. Everything is spatially put in position correctly. I'm going to have to go back and fix that PDU. But everything's in there. If I want to now go do the cracks, I've got all the capability to do it here. I could use manufacturer's equipment from the library, or I could just set this thing up. A crack is a crack. I mean, it's really just a box with an inlet and an outlet on it, and it dumps heat. So if we modify the design here, say this one had 3 outlets and I wanted to define it with 3, I could do that right here. And we have an auto-distribute button that allows you to put them all in. So there's my 3 outlets. I'm using EC fans here, or plug fans, which you scroll down for in the geometry section of the crack editor. You can set the diameter of the plug fan. These are a little small, so 3 is a little better. And you can do that for each one of those, or you can do one of them and just clone it, or Control-C, Control-V it to the other positions. And there you go. Also in CoolSim 4.7, our newest introduction, we have in our pre-simulation report the ability to edit parameters. So here, if I scroll down, you see that cracks are hyperlinked. There's all my cracks lined up with their flow rates, their temperature of thermostat, and their heating and cooling capacity. They default at 10 kW. That's what I brought them in at. But say I wanted to change them all, so I can pick the first one, scroll down, pick the last one with a shift key, get the whole group, right mouse click it, do an edit, change them all at once. So I don't have to touch each one of those pieces of geometry and open their editors individually. I can grab them all at once and just do it. Same thing with airflow or temperature, thermostat temperature. I can do it individually. I can do them with a Control-C to get multiple, but still not all of them. Or I can do it with a shift, which gets them all. Very traditional approach to using keystrokes and so forth. We try to use the same nomenclatures that you're used to using. So you can set your cracks all up that way, and that's going to give you the same results as a library system would for a crack of that capacity. So there you have it, laid it out pretty quick, and that works very well. So this is, let me tell you a little bit about this data center. I mean, this is one of the ones I've seen recently. And what I'm going to do here, you notice in the upper right-hand corner, let me just stop this for a moment, this animation. In the upper right-hand corner, you see my cursor up there taking a look at this Windows. In CoolSim, you can run a split screen, which is on one monitor, you're going to get two views. I'm going to show you that. There's also this dual monitor feature up here that you see, and it's lit blue. And the reason that's lit blue is that I'm using two monitors today. So up here in the upper right-hand corner, you can go with two monitors, which is very nice, but hard for you folks to see on one monitor, me working on two monitors because everything gets too small. So I'm going to use the split view method. It's not something you have to use, but I'm going to use it here because I'm only going to be using one monitor, and that way you get to see what I'm doing a little better. So I'm going to go ahead and use split view. There it is. Now this allows me to have one view in 2D and one view in 3D, and they're synchronized. So everything I do to one view gets shown up in the other view. And this is just another nice illustration of the graphics in CoolSim. Just very nicely done. Uses Open Scene Graph, GL, OpenGL Scene Graph is the engine. And here I just dragged in a duct. And the reason I'm going to put ducts in here is because this model isn't a very good model. This is an upflow, and I've seen these before. This is an upflow design in a classical non-raised data center. And you may say, well, who would ever do that? Well, this is an old site, and yeah, that's how they did it. On a raised floor, they're upflows. So what I'm going to do is I'm going to try to improve the performance of this data center, because today it's fairly horrible. In fact, right after this animation, I'll show you both these models, and that I have them both open, and I'll show you how bad that initial model is. But here what I'm going to do is I'm going to try to improve the design of this model by putting in ducts. And this is a new tool that we've had now for a couple of years, this duct tool. And I can do it again because I'm relying on the Ansys capability. This is a fluid block. And a fluid block is a construct inside of Ansys or Fluent that allows you to put a fluid domain in there and to isolate it from the rest of the environment. And you see with this little tool, I'm able to line this thing up pretty nicely and get it where I want it, and then use the length button to get the length. And I'm looking at the left-hand image to see what it looks like in top view. I'm looking at the right-hand image to see what it looks like in the side view. I can manipulate either one of these by moving the mouse back and forth from one to the other. They're synchronous, so what I get in one is the same as the other. And it's a nice way, particularly if you've got two monitors, to interact with a 3D model and understand where everything is without having to flip it all over the place. Now I can add a duct here, and one of the features we have is this connect feature. All I have to do is hit connect, and it'll add it. I can point at the duct, right mouse click it, say add duct, and then hit connecting duct, and it just connects it. Boom. So that's how my ducts are being connected. Again, these are full fluid blocks. I'm going to get all the flow through here that would be absolutely associated with any kind of duct work. We don't model resistance at the moment inside that duct, but there isn't much anyway, so it's not really an issue, and it is why we don't do it. We may in the future, but we don't at the moment. And we also have Control-C, Control-V. So once I get one laid out, I just grab it, Control-C it, bring it over here, Control-V. So there it is. Now, I do need to reconnect that. I first have to line it up so that it's close. So there's the closeness. And then I really should reconnect those connecting ducts. You can always tell a connecting duct because it's shown in black. So here I'm just going to walk through and reconnect those. The way that the subduct works, the connecting duct, is that it uses a projection algorithm. So you need to draw it back a little bit so that the duct can see, if you're thinking projection, looking down, it has to be able to see the crack. So what we do is just shorten them up. I unclick the connect, draw them back a little bit so the projection can be done, hit connect, boom, and they're connected. So I only have to do that 4 times on this side. Not too bad. So I disconnect and reconnect. It may have worked otherwise, that may have run fine, but maybe not, so why take the chance? Let's just reconnect them because it's pretty quick and easy. So I'm going to open Duct Designer, unhook the connection, bring it back a little bit, reconnect it, done. So now I've got the two header blocks in place, and the question becomes now I want to put ducts all the way across that room to the other side. Now, again, the reason I'm doing this is it appears that there are products on the market that don't have this tool, and you're having to build them by hand using solid edges and make boxes. And so I realized this at Data Center World that people were saying to me, you can do ducts like this? So I wanted to do a webinar and kind of show you that, because this is a very nice tool for doing ducts. It's very fast. And I can do it all right from here. I can add this from this little Duct Designer. I can do all my own ducts without having to interact with the model with the cursor. But it will put them in the center. You notice how it put that subduct right in the center of the duct because it doesn't know where you want it, and then you have to move it to the position you want it to be. So here I'm going to start at the end. I'm going to start making subducts, and I'm going to lay them in. So the first one's there. You can see it in blue, and I'm going to use Smart Length, which projects it all the way until it bangs into something. And the nice thing is it's going to bang into the other subduct. So now I've connected the two together using Smart Length. I didn't have to worry about the length. I just hit Smart Length, and it projects it until it runs into something. Oh, by the way, if it runs into a block, it'll stop. You hit Smart Length again, it'll go through the block. So punching holes in walls becomes very easy with this tool because all you have to do is use Smart Length and it'll project them. So, but the size of this is a little big. The subducts are usually not this large, or they're usually smaller. So you can use this little, again, the Duct Designer tool to shrink those up and position it so that it is where you want it on the subduct and the size you want it. So here, I don't know exactly. I'm kind of iterating with the measurements, but I can see it all happening. CoolSim is a synchronous design, so when you make a change, you can see the change in real time as it occurs. So that looks pretty good. That looks like a pretty good subduct. And then I would do the same thing again for the one further down. So there's my subduct. I just asked for it and plunked it in there, and now I need to drag it to the right location using the sliders, and then I Smart Length it to get it to go across the room, and I change the size and keep on going. So you can build from one side to the other. You can build from a subduct or a main, in this case, a main header. You can build the subducts off it using this little Duct Designer tool and just walk through it and build them in place, and you'll see them all appear as you build it. So that's one method. Here I can see this one, so I just right mouse click it and say Add Duct. You can always point and click with your right mouse, but you can't always rotate the geometry so it's visible to you with the mouse. So you can do it from Duct Designer using the XYZ coordinates and so forth, or you can just point and right mouse click it and say Add Subduct. Do the same thing for diffusers. If you can see it and get at it with your mouse, put your mouse right where you want it, you can just right mouse click it and either add a duct or add a diffuser. So here you see I just pointed and I said Add Duct, and it put it in there right where my cursor was on that main header. I adjust the heights to what I want. I've got the height set 325 in the two directions, and up 175 off the main header, and then I use Smart Length to project it all the way across the room onto the other header block, and I can do that 4 times. So I've got those laid in. Now when I start to do the subducts down into, because I'm going to put these down in front, I got to do subducts down in front of these racks. I can do it using this method. So I'm going to do a subduct that's going to be on my Y min on the bottom of that duct going across, and I want to add a subduct. Now you'll see it in the graphics show up as soon as I add subduct, and it puts it right in the middle because it doesn't know where you want it yet. So it puts it right in the middle, and then we have to change its dimensions because it comes out at the same size as the duct. We don't know what you want for dimensions, so we're going to make it a little bit smaller. And then we're going to drag it into position. We're going to put it where we want it. Length of 2 is okay. We're going to center it. Center is probably going to be 0.5 because we want it right in the middle, or 125. I went the wrong way. And then we're going to move that subduct. You can see it right there. It's not easy to see, but you can see it. And if you put it into split view again, you'll be able to see it over there on the right. And there's my little subduct. Now that's one of them. And I need to drag it into position. And always remember to put a diffuser on the bottom. I see people make this mistake a lot where they forget to let the air out. You can't get air out of a subduct or out of a fluid block unless you let it out. Hence the name fluid block. So you have to put a diffuser on it. So there it is right there, but it's easy to do. You just use the tree to select the one you want, and then you put a diffuser on the bottom of it. So there I've got the dimensions correct, and now I'm going to put a diffuser on it. So that looks good, and those numbers are correct. And I'm going to slide it over. I guess I slid it first. I'm going to slide it. You can see it moving in the upper left quadrant. You can see it moving over on the right. I'm going to get that positioned where I want it. And it records. It tells you exactly where it is. And so you get these 4 digits of resolution. I'll go 16.5. I need to add the diffuser. So on the Y min side, down at the bottom, I'm going to pick Y min. That's the axis I'm working in for that diffuser. I'm going to add the diffuser, set the percent area open to whatever I want it to be. That number is too big, by the way. But anyway, that's what I did it at initially. So there's one, and I have to do that n times for the diffusers and the subducts for each one. So there's my, you can always tell by looking you've got a diffuser on it or not because it's highlighted and identified pretty clearly. So always to make sure you have them. And you can, as I said, you can point and click to make these subducts, or you can use the Duct Designer itself. So here I'm going to use the Duct Designer again. I'm going to add another one, and it's going to be on the Y min side, and I'm going to add the subduct. The duct I'm working on is highlighted in blue. I'm going to add it to my Y min. I'm going to add subduct. It's going to put it again right in the middle because it doesn't know where you want it. And I'm going to have to go in and set those dimensions. Now I've done them once, so I know pretty much what I want. First, I'm going to drag it to the position I want. So in the upper left, you can see it moving. In the lower right, you can see it moving. So it moves into position where I want it. I clean up the decimals. I don't need that much resolution on its positioning. So this is something you'll use on the next one. And that's kind of tedious. That'll take a while to do all those subducts and diffusers. Another way to do it is to copy and paste the subduct. So in this example, what I'm showing you is the idea of creating the subduct independently. So I've got the main header over on the right. I've deleted the rest of it. I've deleted the whole assembly. And I'm going to show you here in 3D how we do this. So over on the right is my 3D view, and I've just dragged a fluid block and set the axis correct so that it's headed in the right direction. And what I'm going to do is I'm going to create the subduct first. I'm going to get it set up. I'm going to put the subducts on it that go down into the aisle with the diffusers at the bottom. And then what I'm going to do is copy paste it so that I don't have to do it n times. I've only done it once. Or clone it. You can also clone it. So here's my duct, and I'm just looking to make sure it's positioned correctly. Once I get the sizes right, I use Smart Length to project it, and that also helps me align it because I need to align it on that main header block over there. And you see that it's off. So I can just sit here and interact. I don't need the sliders. For better precision, I can just adjust it, and it'll adjust in real time. So now that looks pretty good on the bottom, not quite. Might want to move it up just a little bit more. Is 11 too high? Yeah, 11 too high is too high. So I need to do something between 10 and 11. How about 10.5? Now that's still a little bit high. I'm working in feet, so apologize to my international participants. How about 10.25? That looks pretty good. So we'll use 10.25 as the height. Now, how about the other direction? Is it lined up on the header? You can see I'm off by a little bit. That's a Z direction. You can see the little axes in the lower left-hand corner of the scene. So I need to go out on Z a little bit, and to get it onto the main block. So let's try 4. Yeah, 4 looks pretty good. So I got it on there with 4. And so now I've got that one lined up and it's touching because I use Smart Link, so I know that they're going to intersect. As long as they touch one another correctly, you can use Smart Link or you can use connecting a duct. Either way, they're going to work well. I'll leave a gap on the end on the left for reasons I'll tell you in a moment. And now I need to begin to add my subducts as I did before. Now again, you do have to go through this process of, you can't clone a subduct at the moment, although that's a feature we've been asked for. So I do need to lay in each one of those subducts that go down that aisle, and I need to put the diffuser at the bottom, get them positioned correctly using the method I showed you before. So in YMin, I'm going to add a subduct. It pops into the middle because it doesn't know where you want to put it. And then you drag it into the position, get the size you want correct, put the diffuser on it. Never forget the diffuser. A lot of people do. They forget the diffuser. No air comes out when there's a diffuser, and the pressure goes to infinity and the model fails. So there you go. There's the diffuser, and you can drag that into position. Set the percent area open. I generally set them when I'm doing diffusers like this at 25% to begin with, and then you can later on balance it. There's actually the ability to balance these things by changing the percent area open and getting them to flow correctly, and it just helps you a whole lot. We'll show you that at the end. So there's my sizes there, and I go ahead and make those subducts like I did before. There's N of them to make, and for purposes of illustration, I did those for you offline. And now what I'm doing is I Control-C'd it, and I'm Control-V'ing those the entire subduct into position. Very nice. I can take the whole thing and just Control-V it. Control-C, Control-V. I could also clone it. If the offset was the same, I could have done a clone of 3 with a common offset. To attach them, and I wouldn't have needed to attach it either, by the way. It would have been perfect in this direction. But I'd Control-V'd it, Control-C'd it, because they weren't symmetrical. But here I can just open the editor again for the duct, and I can use Smart Link to just project it onto that fluid block. As long as fluid blocks are touching one another, they will conduct fluid, which is a very nice thing. Just a nice feature. Again, this is Ansys technology that I'm using. I'm just exposing it through the CoolSim interface. So being a partner of Ansys, I get to take advantage of all this great stuff they have. This particular feature comes out of actually the IcePack family of products. And fluid blocks are used an awful lot in electronics packaging. So I'm just using some of their technology to make your life easier. So here I drag this one in. I want it in the center of that aisle. I right mouse click it or double click it, either one. I open Duct Designer. It's on the one I want them highlighted, exactly the duct I want. All I need to do is Smart Link, close it, and they're connected. Very nice. So that saved me a lot of time. I didn't have to lay out each of those sub diffusers and subducts underneath. And then over here, I just Control-C the header off to the left. I put it over here on the right, like I showed you before. Line that up. Get that on top of the cracks the way I want them. I would need to reconnect those ducts underneath. Those are connecting ducts. I need to refresh those, but that only takes a second. You simply go in and, like I showed you before, you just flip it around, typically point at it and do a connect on it or reconnect. So you go perspective, it gives you the perspective view. You rotate the model around so that you can get at it, and then you just connect those. In this case, what I'll do, I'm going to delete them. It's almost easiest sometimes to just delete them. So in this case, because I can see underneath that surface, so pointing and clicking is so fast. So I'm just going to unconnect these, unlock them, and I'm going to remove it in this case. And I'll do it for all 3. Might as well. It's easy enough to do, just to recreate those and remove it. And you just walk down the tree. You don't need to go in there into the geometry in the room or in the model. You just grab those subducts and take them out. And now to hook them back up, I'm going to use point and click. So I'm going to close that and just point and right mouse it and say add duct. And then I'm going to do connect. Boom. So it's very easy to hook a duct up to a crack. It's just very fast. You can use these ducts for all kinds of things. You can build objects with them. You can build odd-looking cooling systems that you may run into using this method. You can put diffusers on the front. have the crack blow air out the front. Very handy little feature that we've added here. So there I've added my subducts, connecting ducts. And now I'm using Smart Length again because I'm adding a subduct to the end of this guy right here. Add duct, it protrudes it. I hit Smart Length, boom, connect it. So now I'm connecting these by adding a subduct to the end. Add duct, right mouse click, add duct, Smart Length, boom. I could have connected, I connected the first one using connecting duct, or I can just put another duct on it and use Smart Length. So there's my room, pretty nice. So now I'm going to do a little containment. I had saved off a containment a section here. We contain using baffles, and I just read it in. Another nice thing about the CoolSim is you can write out groups of objects. In this case, I wrote out the containment into a file and put it on my desktop, and I just read it back in. So this is a set of baffles. They are set, I think, leaking at 5%. You notice they're slicing right through the racks. Those baffles go all the way to the floor. You can slice right through a rack in CoolSim and it won't bother it as long as you don't get in the way of the inlets. So you see I move it in enough so that I can actually see the rack inlet in the top view, and that way I know it's going to be all right, and it'll just slice right through the rack and seal up everything around it. And I've got the containment in my buffer because I did a Control-C. It's in my paste buffer. So all I have to do is walk around the room and just Control-V it. Now I do want to align them. So I hold my cursor, I light them both up, hold my cursor and say align to, in this case, Z-min. Hold your cursor over the one you want to stand still. So here I'm going to Control-V because I've already got it in my paste buffer. And I kind of drag it into position. I don't really worry too much about its exact position because I'm going to line it up later. So here I'm going to grab these two, hold my cursor over the one I want to hold constant. So there's the second one. Now hold my cursor over that one, align to, in this case, X min, and it lines them up on the X edge. This makes the mesher happy as much as anything else. It meshes faster, it solves faster because things are lined up and you don't get slivers and gaps in your mesh. So again, I get it close, and then I go to the last one and select it with my Control key. So I've got two selected, and then I right mouse click it and I say align to X min in that case. Now it's filled in that gap there between those racks, which is exactly what I want. So here's the feature right here. Right mouse click it, my cursor's on the one I want to hold still, align to X min. And it fills in that gap just the way I want it to. Here I Control-V again, just like I did before, and you put in all your containment that way. So now I've done a hide on the baffles, so I mean on the ducts, so that I could see a little better. So let's just I put the ducts back in using the show. Right mouse click it, show diffusers. Now that is beginning to look like a pretty good little design. I'm dumping cold air. I call this a bathtub design. You're pouring cold air into the tub. And the tub is the contained area with the racks in it. That's cold air being delivered. Remember, these are upflow units, so this is kind of a nice way to get that cold air into the place that you need them. But the returns are at the bottom, and that's a bit of a mess still because the hot air is going to come out of those racks and want to float up into the room. So what if the room had a ceiling plenum? Maybe the room does, and let's assume in our case that it does, because I'm going to want to use the ceiling plenum to force that hot air up out of that room into the ceiling, through the ceiling, and then back down into the room. So if I get ready to do a simulation here, which I can do, if I've got anything hidden, it will tell me now. We just added that feature. Here's the interface to launch the job, and I can go ahead and launch it just to see how it behaves. But it's going to be kind of ugly because the hot air is going to come out of those racks, and it'll probably feed over the top into the cold aisle instead of going over to the down at the inlet low on the crack. So in this particular example here, I took the same model and I said, all right, well, let's assume we've got a ceiling plenum that we want to take advantage of. And it doesn't have to be much. It doesn't have to be airtight or fancy. It's best if it is. But I'm going to open up the room editor, and I'm going to add a ceiling plenum to this. All you have to do is double click on the room itself, flip a button, And now I've got a ceiling plenum. And I change the geometry here so that I get the right height on that ceiling plenum, whatever I want it to be for depth. In this case, I'm going to set the ceiling plenum to be 4 feet deep. So now you notice this crack extensions that are automatically put onto those cracks because the program is designed to stick those on when there's a ceiling plenum in place. And you're going to need to go in and turn that off. It's not quite smart enough to know there's ducts there. I'm also here going to adjust the height of the room because the room's too tall and I don't want it that tall, so I just adjust it. Notice CoolSim synchronous. I don't have to hit the apply button. I just change the value and it updates the model automatically for me, saving yet a little more time. So there it is, and you see those crack extensions are too tall. They're actually sticking out of the room now. So I just need to touch the editor there for each one of them, open them up, and scroll down and switch off. Everything's adjustable here. Switch off the plenum extension. So I'm just going to walk around and switch that thing off for each one of these, so that the only thing remaining is the duct itself. So this is a kind of a holdover from the days that we didn't have ducts and we only had ceiling plenum returns. So now I've done all that. I did it offline so you didn't have to waste time. And I've got all my ducts laid out there the way I want them. But it would be nice if I separated that return so it doesn't come across the room. So I'm going to use a block here. This is just a geometry block, a cylinder, or else it's a rectangle. And you'll notice here that I can use this thing to be a lot of different things. I'm going to choose in room. This means the block goes from the raised floor to the drop ceiling. And that's automatic. It just picks it up. Now, I also want to make it the length of the room, and I can't remember the length of the room, so I open the room editor. You can have multiple editors open at the same time. And so you just say, okay, the room's 77 feet in the Z direction, so I go ahead and put in 77 feet. Boom, there's my partition that's going to separate the crack units from the room itself. I'm going to change the width a little bit here to be 6 inches, just because I don't need it to be so big. So there's my wall. Notice the fluid block is going right through the wall. I'm going to Control C over here, Control V. I don't need to worry about punching a hole because the fluid block has priority. It'll blow through anything. You can get it to go through blocks, baffles, racks. It goes through anything. Fluid block has priority and can and will go anywhere. So here I'm just laying this thing out, and I've got my 2 blocks in place. Now I need to put some grills in. So I need to put some return grills. Got to let the hot air up into that ceiling plenum. So again, I get the first one set up and set the percent area open the way I want it, get the length in place. And once I've got one set up, I'm going to use, and I can use endpoints or size. I tend to use size unless I'm trying to match an end somewhere. I use size. You can guess at the size generally. This one, of course, would probably be 4 wide. But I can guess at the size and the length direction and just watch the graphics to see where it ends up and adjust accordingly. So a lot of times if you don't know a size, you can sort of just estimate it, and the thing's fast enough in terms of graphics to be able to allow you to just get it right pretty quickly. And then once you have one, again, you Control C, which puts it in your paste buffer, and then you can just Control V it. So I Control C, and then I Control V over here, and so on down the line into my hot aisles. So now I'm dumping the heat up into the room, getting it out of the way of the cold air supply. Again, I haven't done full containment because in this case, I didn't want to. Now, often that's because you've got overhead fire suppression that you need to deal with, or you've got cable trays up there that you have to deal with, and full containment is complicated in many of those cases just for that. I do want to line these up, so I select them all, put my cursor over the one that I want to hold constant, line them up in the X direction, do the same thing over here, Control C. I'm just selecting with my left mouse button, put my cursor up on the one to hold constant, align to X min, boom, they're all lined up. Now, don't forget, you got to supply a way for the air to get down to the intake on those crack units. Oh, I guess I lined a few up in the other axes as well. Meshers like things lined up, folks. They do. So I tend to line up my geometry pretty closely, if whenever possible. So yes, I'm going to use size here. I need to let the hot air into the crack gallery. So here I'm going to open it up pretty far. I'm going to, oh, I see I adjusted that grill down there. I didn't need it to be that long. Sorry. So in the lower right-hand corner, I'm adjusting that grill because it doesn't need to go the whole length of the room because the rack isn't that long. So now I have to put a grill in because I have to let the hot air down into those intakes. So here I set it up. I want it to be a pretty high percent area open. You could cut a hole without any grill at all, would be best, but we'll set it at 80. I'm going to use size and make the thing probably this return 4, maybe 6 feet wide. But I need the length to be long enough to go all the way down the whole length of the room. Again, don't worry about the ducts. It'll slice through them. In this case, you don't need to because the diffuser, the return grills are above the ducts. But there you have it there. And now once I like it, I just Control-C, Control-V to the other side. And there you have it. Okay, so now my model is pretty much set up and I'm ready to run. And if we shift this thing into 3D and take a look at it, that's a pretty good looking data center. Here again, I'm aligning my returns. But that's a nice design now. Now I'm dumping cold air into those cold aisles. I have eliminated the leakage back to the crack units, you know, and forced the air to go up, the hot air to go up into the roof. So I want to show you those two models now. So I'm going to pop out of CoolSim for a moment. I'm going to show you those two models before we get to the end. So here are the two models. The first one is shown here. This is the first model, and you can see that it's, you know, and you kind of laugh at this and you say, who would ever do this? But I recently worked on a project by a major IT corporation that had it laid out like this. So, you know, these legacy data centers are laid out. This happened to be switches, a bunch of switches in here. So they weren't high power. But you've got all kinds of stuff going on. So this is the CoolSim output. And let's just take a look at the write-up of it. This is a data center that has a cooling capacity of, what is the cooling capacity on this thing? Total number of units, 8. Flow through them. Total heat removed, 395. But the capacity on this thing is quite large in terms of total cooling capacity. It took the heat out okay, but it's really not very good. If we take a look at the coefficient of performance, it's terrible. It's down around 1. Its PUE is above 2. RTI of 13, that's supposed to be a percentage. So the ratio of the two, supply versus return, is just horrible. Take a look at the flow rates. I'm giving it 305,000 CFM, and I'm only requiring 39. It's just crazy. If we take a look at the crack performance down here, we'll find the delta T is 4 degrees. It's just awful. So in this room, you've just got a whole bunch of mixing going on. So here's the airflow coming from the crack units. It's just going everywhere. Complete mix going on in the room. The return airflow is no better. This shouldn't surprise you at all, of course, because this is what's going on here. So this is the results viewer in CoolSim. It's a new results viewer, and it can be shared with your customer if you want to share it. But look at the hot air coming out of here and just going everywhere, including the inlets of the adjacent rows. It's just going everywhere. It's a completely mixed environment, and it's a mess. And the total capacity you can get out of this thing, let's see if my inlets are hot. And these are my rack inlets. This is a conformance plot to the ASHRAE spec. And no, there's no problem there, but that's because the wattage is so low. I mean, we're only dumping 382 kW of heat. Now, in the next model, what I did is built it like this. This is the one that I just showed you. So this is the input side. Now we were able to turn up the load quite a bit in this room and get more effectivity out of it. We didn't change the total cooling capacity. What we did is we changed the total load. So let's take a look at this one from an energy point of view. the COP went way up to 3 because our return temps went way up, and we're getting more effectivity out of it. PUE dropped to 132. RTI is down now around 75, 76%. Not great. You'd like to see that 100. RTI, by the way, is a ratio of what the racks need compared to what the cracks are supplying. So again, if we look at what the cracks are supplying, we see the cracks are supplying 305 as they were before. The racks need 231. You'd like to get that closer, but we're not fully contained in this design. So it's hard to get it any closer than that without having some leakage. But look at the dollars here, 2.5 million to operate it, but the PUE is down at 132 and the total load went up. So let's take a look at this one from a pathline point of view and see what's going on. So from the ducts and diffusers, let's have a look and you can see what the air coming out. So the air is coming out of these diffusers and I'm getting a little bit of return circulation, bypass airflow back from the diffusers into the ceiling from the supply diffusers. So there's a little bit of bypass airflow going on there. It would probably be best if I went in and ratcheted down the diffusers right here, the percent area open on this one and this one be a little lower. Got the same problem here. I'm losing a little bit right there. It's going back into the ceiling, so there'd be an opportunity here. Notice the effective momentum. The air is probably coming from this direction because I've got a momentum effect going on here, which isn't helping much. But there's the air coming out. By the way, this has a new feature in it as well, so that you're able to actually isolate surfaces. You can turn things on or off. Like if we wanted to turn the rear of the room off, if we wanted to turn off the baffle surface, or in this case the duct surface, so we could see those path lines a little bit better, we can. So this feature is very nice, and this is a free viewer. You can share this with your customer and let them view things in 3D. Let's take a look at the return air. The return air tells a big story as well. So it looks a little busy at first. Let's zoom in on it and take a look. And you see that there's my hot air coming back, and it's doing what I wanted it to do. It's going up into the ceiling and coming over. But it also looks like it might be wrapping up over the top and getting into the intake of some of them. So now it's a little hard to see because the wall's in the way. But again, we have this nice feature over here where I can turn off surfaces. So I can turn off the block surface, and I can also turn off the duct surface. And that allows me to see those hot air lines kind of nicely. And if we look at it from this point of view, you see that the hot air is coming out and some of it's wrapping up over the top. It's not going into the ceiling grills quite so easy. So that may mean my ceiling grills are a little small or positioned incorrectly. If I made those a little wider up there, chances are I'd capture more of it. Same thing here, it's wrapping up around. Now, this is a very good feedback for the design person to see that, it might be that you want to make those return grills a little bit bigger because it's wrapping up around here as well. So these visualization tools are really handy to help you understand what's going on in the room before you get there. You can even balance them out to the point where you know roughly what the balance is going to look like on the percent area open for the diffusers. It's just a very nice feature. By the way, if you want any of these shots to be saved as a PNG, you just orient it the way you want. You hit the P key, and it writes it out as a PNG file down here. You see, I can do a save as, and I can put that on my desktop or wherever I want it, and it'll write it out. So very nice viewing environment for CoolSim. Let me just park back. We're running out of time here. We're a little bit over, so let me just go to the final slide and show you that the initial condition was 2.4 megawatts of total cooling capacity and a max load of 382, and a PUE of 2 and a delta T of 4. Total cost to operate for a year, about $692,000. We improved the design. We were able to take the total load to 2.2 megawatts. So that's quite a difference, factor 7, I think. We dropped the PUE to 132. The delta T we got to 22 degrees, almost 23 degrees. Total cost to operate went up because the IT went up. But this little calculation is kind of interesting. The total cost per IT watt. I mean, at the end of the day, what you're doing in a data center is you're producing an IT watt. You don't know how many MIPS or flops that IT watt's going to produce because that's up to the computer. But at least our job, yours and mine, is to give them the best relationship between the IT watt and the cost to run it as you possibly can. That's what this is all about. How cost effective can we be? And you notice we went from $1,800 per watt for a full year. That's a yearly number. That costs 1,800 watts to run that IT load for 1 year, compared to less than $1. So that's almost a 2,000-fold improvement in the yield or the output of that room without changing the cooling system. All we did is put a wall in. We used a ceiling plenum and some sheetrock and some duct work. And that's a pretty cheap investment. Return on this would be very, very high. We just made that data center yield a lot more capacity without changing the cooling system. So that's it. It's a little after the hour. I will entertain any kind of questions you might have. I was trying to point out today, in a very short amount of time, how easy this thing is to use. You can bring it in from CAD, you can set up the model and give it a run and learn an awful lot of important stuff using this tool. The duct tool is unique. It's a very, very nice feature. It allows you to clone the duct. You can copy paste it. Rack Builder allows you to put the loads where you want them in the rack. The meshing works really well. The product is extremely robust. It just plain works. And it's accurate. It's very accurate for predicting the cost to operate data centers and how to reduce the cost. And that is becoming increasingly important in both the colo market and the end user market. Cost is the big issue, and our ability to predict that is getting better. We are also predicting energy analysis in this tool and doing more of that over time. So if you have any questions, please go ahead and type them in. I don't see any at the moment, so I'm assuming that everybody is good with questions. But if you have any questions and you want to reach out, you want to take a look at the tool, you want us to review anything with you, we'd be certainly willing to do that. And I hope this hasn't gone too fast for you. I know that it was quite a bit in just 1 hour. But on the other hand, the tool is fairly quick to learn, quick to use, and I hope you were able to get that out of it. Again, thanks. My email is here, paul.bemis@coolsimsoftware.com. If you have any other questions, you want to talk about it, please let me know, and we'll do that for you. Okay. Thank you, everyone.